We're always talking about making AI smarter. But what if the key isn't just a bigger brain, but a completely different kind of brain? That's the incredible promise of what might be the next big leap in artificial intelligence, Neuro Symbolic AI. So let's just think about this for a second. Imagine an AI that could learn from the messy, unpredictable, chaotic real world, just like we do. But at the same time, it could reason about that world with cold, hard, perfect logic. That's the future we're talking about today. All right, so to really get this, you've got to understand that for the longest time, AI has kind of had these two competing personalities, two different brains, if you will, and historically, they have not gotten along. So, in one corner, you've got the learner. This is the neural AI we hear about all the time, systems that learn by spotting patterns in huge amounts of data. It's what's behind image recognition and LLMs. But here's the catch. It's a complete black box. We often have no idea how it gets its answers. Then in the other corner, you have the reasoner, or symbolic AI. This is kind of the old school AI, a master of formal logic and rules. It's totally transparent and explainable, but man, it's also incredibly rigid. It needs everything to be perfect. Okay, so you have these two powerful approaches. But here's the problem. On their own, they each have a huge, huge blind spot. And when they can fail spectacularly. Let's start with the learner, the neural AI. The thing you have to remember is that these systems are basically slaves to the data they were trained on. They're amazing at recognizing patterns they've already seen, but the second you throw them a curveball, something even slightly new, they can just completely fall apart. And this is a huge deal. A researcher in this space, Paulo Shakarian, put it perfectly. They can't generalize beyond their training data. And that's not just an academic problem, right? Think about it. That could mean a self-driving car mistaking a person for a traffic cone just because the lighting is a little weird. That is a massive risk when a system only learns by example. Now, the reasoner, it's got the complete opposite problem. It just can't handle the messiness of the real world. It's like a world-class chef who literally can't cook unless every single ingredient is perfectly measured and prepped for them. A human expert, what they call a knowledge engineer, has to painstakingly translate the entire world into perfect little symbols and rules for it. As you can imagine, that's a gigantic bottleneck. It just doesn't scale. So what do we have? On one side, a brilliant but kind of flaky artist. That's our neural network. And on the other, a super smart but totally inflexible accountant. That's our symbolic system. So what do? Well, you make them work together. And that, right there, is the core idea behind neurosymbolic AI. It's about creating this incredible hybrid, a power couple. You let the neural network do what it's good at, making sense of all the messy, real-world stuff, and then you have the symbolic system provide the clear, logical, explainable reasoning on top of it. Of course, getting them to actually talk to each other, well, that's the billion-dollar question everyone's trying to solve right now. And you want to know what's so wild about this? This whole two-brain approach? It's basically how our own brains seem to work. Think about Daniel Kahneman's idea of System 1 and System 2 thinking. We all have that System 1, that fast, intuitive, gut reaction, the thing that lets you recognize a friend's face in a crowd in an instant. That's the neural network. Then we have System 2, our slow, deliberate, conscious reasoning, the part that solves a tough math problem. That's the symbolic system. Neurosymbolic AI is literally trying to build both of these systems into a machine. Okay, so this isn't just some cool idea stuck in a research lab. This two-brain AI is actually out there, in the wild. Some of the biggest companies in the world are already putting it to work on some really tough problems. Let's look at Amazon's guardrails. Here's how it works. You've got these super long, complicated company policy documents full of jargon, right? First, they use an LLM, that's the neural learner part, to read that document and translate it into clean, formal logic. Then it does the same thing with a person's question. Finally, the symbolic reasoner engine takes over, compares the two, and gives an answer that's always consistent and, most importantly, completely explainable. No more guesswork. Or how about DeepMind's Alpha Evolve system? This one is really cool. It uses a creative LLM to just brainstorm and propose new computer programs. But then it has a symbolic verifier, the logical part, that acts like a super strict fact checker. It goes through the proposed code and makes sure it's correct and efficient. This dynamic duo even found a faster way to do a fundamental calculation called matrix multiplication, which could speed up all kinds of computing. So yeah, finding faster algorithms and making sense of company policies, that's great. But the real reason this matters, the reason we should all be paying attention, goes way beyond that. This is about building AI that we can actually trust with our lives. In high-stakes fields like healthcare, you don't just want an AI that spots something on a scan. You want an AI that can tell the doctor why it flagged that spot, based on established medical rules. For self-driving cars, you need a system that can perceive a pedestrian with its neural side, while strictly obeying traffic laws with its symbolic side. And in finance, we need AI that can make fair, explainable decisions about who gets a loan. Ultimately, this is all about building AI that's not just smart, but also safe, reliable, and accountable. So, we've seen how powerful it is to bring these two AI brains together. But it makes you wonder, right? Could this combination of learning and reasoning finally be the key? The thing that unlocks not just artificial intelligence, but maybe, just maybe, something a little more like artificial wisdom. Now, that's a question to think about.